The electrical stability of the heart relies on a highly synchronized sequence of cellular events known as the cardiac action potential. This impulse is governed by the intricate opening and closing of specific voltage gated ion channels residing in the cardiomyocyte membrane. When genetic mutations alter the structure or regulatory proteins of these channels, it leads to a cardiac channelopathy. These are primary electrical disorders that predispose individuals to life-threatening arrhythmias and potentially sudden cardiac death, often in the absence of any structural heart disease. The cardiac action potential is shaped by a delicate balance of inward, that is depolarizing, and outward, that is repolarizing currents. Sodium current. The protein is NaV 1.5. Gene is SCN5A. Primary function phase 0 rapid upstroke depolarization. L-type calcium channel current CAV 1.2. Gene is CACNA1C. Primary function in phase 2 plateau and excitation contraction coupling. IKR protein is HERG KV 11.1. Gene is KCNH2. Primary function is in phase 3 rapid repolarization. IKS, that is the slow component. KCNQ1 gene, that is KV 7.1. Primary function in phase 3 slow repolarization. Sodium channels. The NaV 1.5 channel encoded by the SCN5A gene is responsible for the massive rapid influx of sodium ions that initiates the action potential upstroke, that is phase 0. Because it dictates how fast the electrical signals travel, abnormalities here often slow conduction and favor dangerous re-entry arrhythmias. Potassium channels. Potassium currents drive repolarization, returning the cell to its resting state. The two most critical are the rapid delayed rectifier current IKR generated by the HERG channel and the slow delayed rectifier current IKS generated by the KCNQ1 channel complex. Because these channels are heavily interdependent, a defect in just one can destabilize the entire electrical cycle. The most prominent inherited channelopathies include long QT syndromes. LQTS is characterized by a delayed repolarization of the ventricles, visible on an ECG as a prolonged QT interval. This delay creates a vulnerable window where early after depolarizations can trigger TOS at the point, a polymorphic ventricular tachycardia that can degenerate into ventricular fibrillation. LQTS is classified by the specific mutated gene. LQT1 caused by loss of function mutations in KCNQ1, that is the IKS current. Arrhythmias are often triggered by exercise, especially swimming or emotional stress. LQT2 caused by loss of function mutations in KCNH2, HERG channel, IKR current. Triggers often include sudden loud noises like an alarm clock or emotional stress. LQT3, unlike LQT1 and LQT2, this is caused by a gain of function mutation in the SCN5A sodium channel, leading to a persistent late sodium current that drags out the action potential duration. Events typically occurs during rest or sleep. Brugada syndrome is most frequently associated with the loss of function mutation in the SCN5A sodium channel gene. It is diagnosed by a very specific ECG hallmark, a code type ST segment elevation followed by a negative T wave in right precordial leads V1 to V3. Patients are at high risk for syncope and sudden cardiac death due to ventricular fibrillation, often occurring at night or during a fever. Short QT syndrome is a rare but highly lethal channelopathy characterized by a dangerously short QT interval. It is primarily caused by gain of function mutations in potassium channel genes KCNQ1, KCNH2 or KCNJ2. Because the potassium channels stay open too long or open too forcefully, the action potential repolarizes much faster than normal, shortening the refractory period and allowing atrial and ventricular fibrillation to take hold easily. Catecholaminergic polymorphic ventricular tachycardia (CPVT). While the channelopathies above primarily involve surface membrane channels, CPVT is a defect in intracellular calcium handling. Mutations in the ryanodine receptor or calsequestrin cause calcium leak from the sarcoplasmic reticulum during periods of high adrenergic stress like intense exercise or emotion. This calcium leak triggers delayed after depolarizations, leading to bidirectional or polymorphic ventricular tachycardia.